Hello. It's great to follow on from that presentation from Chi. Obviously, I've used a lot of their resources online in doing the research that I've carried out. Before I get started, I just want to introduce myself a bit more. I'm a wall painting conservator, so I come at this technology from a slightly different point of view from a lot of the presentations that we've seen so far. I'm a freelance wall painting conservator working in London with the Courtauld Institute of Art. They work mainly on international projects that I work with, but the two projects that I'm going to discuss today are at the Royal Gallery in the Palace of Westminster, which is this image here. The painting isn't blue. This is a fluorescence or luminescence image, and also the painted hall in the Old Royal Naval College at Greenwich, Maritime Greenwich in London. So for me, what's been interesting over the past couple of years as I've investigated 3D documentation techniques for the application of wall painting conservation is the ever-growing availability of both the hardware and the software, and the greater user-friendly nature of capturing 3D data. That means that non-specialists in the field, such as conservators, can now start to use these techniques themselves where the technology is available to them. So the two projects that I'm going to talk about, the kind of primary output from the projects is not necessarily the 3D data, but as Chi was talking about, it's the kind of 2D orthographic images that are the primary output focus for the projects. And what I've been trying to investigate is combining this technology, photogrammetry, with multispectral imaging, and seeing if it's possible to combine these technologies to create better documentation of wall paintings using different light sources and different sorts of imaging techniques, and seeing if they can be overlapped and worked on a much greater resolution and to a greater scale than they have done in the past. Usually with multispectral imaging image sets, the size of the sample area is usually quite small, maybe a metre squared, whereas in these cases I've been applying it to wall paintings that are more like 10 metres squared or bigger. So these are just the two the two sites that I've been working at. On the left here, as you look at the screen, this is the painted hall at Greenwich, and then on the right, it's this is the Royal Gallery just outside the House of Lords in the Palace of Westminster. And so the paintings in the Palace of Westminster are about 11 metres long, and the paintings on the ceiling at Greenwich are about 3 times as long as that. So the documentation was the kind of was one component of in the preliminary stages of these wall painting conservation projects, and the time constraints necessitated that the high resolution documentation is captured quite rapidly. Particularly at Westminster, the room is a very high profile room that's constantly in use. Essentially it's an open plan office for the Lords, and is also used for state functions, and so getting access to the room for photography is very difficult, and so when access is available, capturing the highest resolution, best data that you can is kind of imperative. But just for future reference, the windows above the paintings become important in terms of the conservation project and the use of the output images that I've created. So in the Royal Gallery at the Palace of Westminster, the two image sets that were captured were visible and UV luminescence images, and I'll go into a little bit later on what the UV luminescence images are. But the two paintings are on plaster. They're a technique called water glass paintings, which is quite a specific technique used in Northern Europe to replicate the effect of true fresco technique, which is where the painting is executed on wet plaster rather than dry plaster. And I think there are a couple of examples of this technique in America. But the paintings depict two of the most important battles in British military history. On the right there you have the Battle of Waterloo, and on the left the Battle of Trafalgar. These are painted in the mid 19th century by Daniel Maclise. And so the project scope was to capture them in visible and UV luminescence images, and the resultant images that were then used both as a record of the present condition of the painted surface prior to the conservation project, which is ongoing, and also to investigate the physical history of the paintings with reference to original and non-original added materials such as coatings and areas of repainting. And it's also being used as a monitoring tool during work on the stained glass windows above the paintings. And this is the old Royal Naval College at Greenwich. The building with these paintings is to the right there, and it's slightly behind this building in the foreground. It's painted by James Thornhill in the early 18th century, and the building is by Christopher Wren, and the building was built in the late 17th century. So as I said before, the project aims are more or less the same for both the sites, but at the Royal Gallery essentially the difference is that visible and UV luminescence imaging was done, whereas in the painted hall visible and IR reflected imaging was done. And this is because it was not possible to do the luminescence imaging in the painted hall because all the imaging was done from the floor here, and to do the luminescence imaging you have to get within a couple of meters of the paintings themselves due to logistical and technical reasons to do with ambient light and the amount of radiation we can produce from the flashes. Just a little bit about the documentation of wall paintings and why photogrammetry is particularly well suited to wall paintings. As we can see, wall paintings are often monumental in scale. They have a three-dimensionality. They're often heterogeneous in terms of condition, original technology, and also added materials. And therefore, accurate and effective documentation of wall paintings is a technical and logistical challenge. They vary spatially. How do we capture this information? How can we capture this, all these different surfaces? For example, in this room here, more or less all the different surfaces within the room are painted. So being able to capture this three-dimensional nature of wall paintings is particularly important. So large-scale recording of this complexity is paramount for effective conservation, development and implementation. It can inform our it can inform our understanding of materials, and it can help us form hypotheses regarding deterioration phenomena, and it can also help us develop treatment proposals. It can help us understand access requirements. Where do we need to build scaffolding if we're going to conserve these paintings? It's an extremely expensive undertaking to build scaffolding in this space, and so do we need it everywhere, or do we only need it in a localized space? So high-resolution photography and 3D digital documentation tools can help us investigate prior to the scaffolding where we might need to access. Here's another example. This is a Byzantine church in Cyprus, just showing again the three-dimensional nature of wall paintings means that conventional photography falls short of documenting them accurately. Distortions due to single points of view, areas that are not visible, domes and arches, recessed niches, objects in front of them. How can we use the technology available to us now to accurately record these wall paintings in the same way that the building structure itself is recorded? Because wall paintings and the building structures are entirely interlinked, and so the best form of documentation of the wall paintings is often the same as which can be applied to the building. The challenge of documenting wall paintings is not only that, it's also the location where they are. often wall paintings have a public, social, religious function, meaning that access to them is usually restricted or difficult to negotiate. This is the House of Lords and the room next to the one that I was doing the project in, and it itself has wall paintings above the high up on the ceiling. The use of the building renders access to these paintings extremely difficult, so we need to use technology to help us both record them and investigate their condition to help develop treatment proposals. And then on the left here we have this is the Royal Gallery again, but after the scaffolding has gone up in the Royal Gallery, and the wall painting is actually now behind that plastic protective sheeting. So once that scaffolding is up, photography of the wall paintings is more or less is extremely difficult in any meaningful sense. So the provision of platforms and scaffolding is a common and costly necessity for imaging and other forms of recording. Whilst it improves access to the painting, it also limits flexibility, field of view and position relative to the subject. We also have obstructions, often to do with the devotional practices that in some instances are sacred and can't be moved. How can we use technology to negotiate these things? So moving on to Greenwich, where we have also, again, the spatial complexity of wall paintings. These are the paintings that are in the dome of the vestibule, and the very nature of this domed shape to the wall painting means that conventional photography can't really accurately capture the information. Also, from the ground, you can't actually see all these all the wall paintings because of the dome shape, and therefore capturing them in 3 dimensions facilitates the general public from being able to see these paintings. We can also visualize them in orthographic projections to help us understand their relationship to the architectural space. This is a series of ceiling panels in a Rajput palace in Rajasthan from the 18th century, where we've got severe problems of delamination of the wall paintings away from the ceiling itself, and so being able to correlate that condition to the failure in the structure of the building is particularly important to understanding how we could, what the causes of the failure in the wall paintings may have been. And these are techniques, or ways of visualizing the wall paintings that have not really been applied, have only recently been, the technology for the conservator to create these images has only really been very recently available. We also have the material complexity of wall paintings, both in terms of the pigments that are used to create them, and also applications such as varnishing, gilding. That's one aspect of their material complexity. The other is the condition which they are in. Wall paintings are often, the condition of wall paintings is often subject to aspects of the structure itself or other external forces, and this the fact that wall paintings are the interface between the building and the external environment means that their condition is often particularly bad. So how can we record all the different things going on within this image? Actually hidden beneath this image is that very beautiful Baroque wall painting. But how can we begin to understand all the different overlapping conditions that will help us restore them? The common way to do this is using graphic documentation to map different condition phenomena and also different aspects of original technology. This is an example from a cave site in northern India where photogrammetry has been used to model the cave. It's a very small cave on conglomerate rock, and photogrammetry has been used to create a model, and that model, therefore, we can use an orthographic image exported out of the model to more accurately represent the wall painting itself, and then also more accurately map our condition phenomena and original technology. So as I mentioned before, I've applied photogrammetry not only to standard photography, that is reflected visible light, but also to luminescence imaging. And I've combined these techniques to spatially record the materials and conditions of the wall paintings. For more information about multispectral imaging and the techniques used in this case, you can refer to a British Museum project, the Charisma project, which is available on the British Museum website, that provides guidelines and software about how to create different types of reflected images and also different types of luminescence images. So the methodology I've applied has been a flash-based system, which is particularly good for documenting wall paintings when often the photography is done off scaffolding or in tight spaces. In the past, lamps have been used, but the advantages to using a flash-based system are the fast shutter speed and speed of capture that allows us to capture more images more quickly. The technology is relatively low cost and available off the shelf. The size of the areas that can be sampled in a single image is limited only by by physical considerations such as architectural space, available lenses, and as well as the power of the radiation source. And also, as we can use the fast shutter speeds because of the use of flash, it allows us to cancel out the ambient lighting in the room, which in the case of the Royal Gallery with the stained glass windows, it's not possible to control in the daylight. In the past it would have been done at night, but because we can use very fast shutter speeds, we can actually do it during the day, and not all have to come in the middle of the night, which is advantageous. So this is a diagram of the difference between reflected and luminescent imaging. Here we have visible reflected imaging and infrared reflected imaging, where the light or the radiation shone onto the wall painting or whatever it is you're photographing is the same that which the camera detects. Whereas in luminescence imaging, for example in the standard UV induced visible luminescence imaging, you shine UV light onto the wall painting, and what you capture is visible light, and it's separate from the UV light, and therefore any visible light that the camera detects is either created by the wall painting itself or the painting itself, or it's from another source in the room if you haven't calculated in ambient conditions, or maybe there is some parasitic light in your radiation source, but we can include reference samples within the images that helps us understand what is actual luminescence and what is just parasitic light. So this is a very nice example of where it can be practically used. This is a painting in Rajasthan of Krishna, and on the left here we have the normal visible image and then the UV luminescence image on the right. And the difference between the two images is that the colour that you'll see in the image on the right is all produced by the painting materials itself after excitation with UV light. And what we're seeing is this bright yellow fluorescence in the areas where we've got a yellow pigment. And what that's telling us about the painting is that it's probably an organic pigment, and it is an organic pigment, which has implications for the conservation treatment that we would use. You might not actually be able to see in detail, but if you zoomed in on this image, you would also see tiny specks of orange fluorescence, which is the lapis lazuli used in the blue, which is an impurity in natural ultramarine, and that's fluorescing. And so we can use this to non-invasively identify the use of lapis. And another technique, so we've got a visible image, an infrared reflected image, and we can combine these two images to create an infrared false color image, where we're taking the red channel of the infrared image and the the red channel of the infrared image and the red and green channel of the visible image, and then putting them together in a composite image known as a false color image that helps us, that can be used against reference standards, to non-invasively identify pigments, and also to visualize differences in the painting and how the painting is responding to the different forms of light that can give us information about maybe its history or its condition. So how does this relate to more general survey techniques in terms of wall paintings? We need to think about what it is that's needed in terms of wall painting conservation. What it is needed is techniques to capture the scale and complexity of the subject, and also the colour and surface information, because obviously it's a painting, so we're interested in the colour, but also the surface information about things like presence of coatings, varnishes, whether the surface is deteriorating or whether it's in good condition. So in the past, rectified photography has often been used, but it has certain limitations in comparison to photogrammetry, which is becoming much more increasingly available, where we can capture high quality RGB images that can be used to create both 3D models, as we've seen, but also these high resolution orthographic images that allow us to kind of virtually inspect the wall painting from a distance. And then we have laser scanning, which for the purposes of my use is not something that that's been available to me, because obviously it's very expensive, but then also it doesn't have the advantages that photogrammetry may have for our interests in terms of colour and surface information. So if we look on this handy diagram from a CEPA conference, we can see that wall paintings fit somewhere in the 1 to 10 metre range, and the complexity of the object is such that close range photogrammetry or laser scanning is a nice technique to choose. So this is an example of the orthographic images, orthomosaics, that were created, and this is the Painted Hall in Greenwich. What we're interested in as wall painting conservators is being able to move into the highest resolution possible through the images that we capture, so we can begin to understand things about why the painting is maybe deteriorating or why it needs conservation. In this case, it's to do with the presence of a varnish that is altering and obscuring the painting. And so being able to map from the floor and look at the painting in this kind of detail really helps us, prior to the erection of scaffolding, to understand what may be going on with the painting, and also target certain areas that for further investigation. So in terms of photogrammetry and capture methods for what we might need to do, essentially wall paintings fall into all of these categories. We may have a facade like we do at Westminster, or an entirely painted interior space as we saw in the Byzantine church, or we may have a column or other architectural features where we would need to adapt the capture methodology to get the information that we require. So these recent advances in structure from motion software packages can be coupled with the fluorescence and infrared imaging, as we'll see in a moment. So as we've seen in the last presentation, so I don't need to go into too much detail about capture techniques and the best methods for doing this, but we have an overlapping unordered image sequence that we can use to produce a 3D model, where each point in your subject needs to appear in so many photographs, 9 it seems, and images can be captured using handheld captures and off-camera flashes, which is particularly good for relatively fast capture of images. So this is an example of the sequence of images captured at Greenwich. So really the advantage for the wall painting conservator is that there's no specialized equipment beyond photographic equipment that we already have available. It's the software that is the more expensive and more unusual component to this for conservators. So the structure from motion software packaging merges these different photographs and calculates the position of the photograph, creating this 3D mesh. But really, as a conservator, in terms for paintings, what we're interested in is the color information. And the final resolution is a result of those original images. So the higher quality original images that we get, the better the information that we might finally have in our final orthomosaic or model. And so this is the battle of Waterloo, and so it's not Napoleon. It's Wellington meeting Blucher just after the battle. It's a fantastic painting, but conservation is mainly focused on presentation issues to do with this painting. And so we're really interested in aspects of the physical history of the painting to do with the application of coatings and varnishes and areas of repainting that we may want to reduce to improve the legibility of the paintings, because essentially if you go into this space, there's a beautifully gold room and there are these very dark wall paintings, and so the focus of the conservation project is how to improve their legibility. And one of the proposals is better lighting in the space, because as a result of the investigations into the surface of the painting, it's been decided, or it's in the process of deciding, how much should be done physically to the object and how much should be done changing the lighting in the room and other conservation choices that we have. So for the photography, for the visible and luminescence imaging, a Nikon D810 was used, whereas for the IR images, you have to adapt a standard camera and take out its internal IR filter and replace it with a quartz filter. And so the radiation sources are the same for all the different types of imaging, except for the visible imaging, we have different filters on the camera, and then for the IR imaging, we change the filter so we just see the infrared light, and then for the UV luminescence imaging, we put some filters on the flashes, and then also put some different filters on the camera itself, so we can selectively choose what type of light is both shone on the painting and that which the camera captures. And so the color is accounted for by using a Macbeth color checker, except the UV luminescence images, because white balancing doesn't apply in the standard ways, because essentially we're photographing a light source of an unknown color, and so it's set to a neutral cloudy setting. And then we also include spectralons, which allow us to calculate how much reflected light is in the image, as opposed to how much luminescence is in the image. And so up to 700 images were captured for each for the paintings, and they were processed using my computer, which had limitations. So where I essentially crashed my computer, I could break the paintings down where necessary, and for all the processing of the models, the quality settings were set to medium. So this is an example of the capture technique in Westminster. My scaffolding wasn't quite as movable as they had for the Diego Riviera, but I had a team helping me there. So essentially, I was about 2 meters away from the painting. That's determined by the distance you have to be from the painting for the UV luminescence imaging, and I worked my way along the painting, capturing many images, whilst the room is being used by the Lords, and that was particularly important to get permission to do the imaging. It was to not shut the room, because if the room gets shut, people start shouting, essentially. So this is an example of the imaging with the flashes, with including the reference material to help us calculate what's happening in the images. And so for the Westminster paintings, there are approximately 50 meters squared each. And we have a lack of control over the ambient lighting, meaning that we need to use the flash-based system. And so this is an example of one of the images. And you can see here, these are our spectralons. So the whitest image, which is a bit blue, is a reflectance material. So all that is actually reflectance and not luminescence. so we know that there is some reflected light in our image, and we can use the British Museum guides to help us subtract that out, so we can begin to look at the images and understand what's going on with them in terms of the information that they reveal to us. So this is an example of one of the images that was captured covering the entire space of the wall painting, and revealed to us is aspects of essentially the paintings have been heavily repainted, and this is kind of creating a muddy effect on them, and they've also had many different applications of varnishes and coatings, some of which had been attempted to remove, creating a kind of patchy, uneven effect to the paintings. So being able to map this across the whole surface of the painting is an extremely good tool when it comes to treating the paintings and potentially improving their legibility. So again, we've panned across the surface, capturing our image set in both visible light and UV-induced visible luminescence. So we can see, for example, there's a slight red fluorescence to his red jacket, which seems to have been repainted, and also a similar pigments have been used in areas of his face, such as his ears and on his cheeks. And we can also begin to compare differences between areas of the repainting. So these are the two paintings, Trafalgar at the bottom with the death of Nelson. Nelson's lying there, dying in the middle, and Waterloo above it. So these are the visible reflected images, and then these are the UV-induced visible luminescence images. So we can look at the whole of these paintings in UV light and to a very high resolution based on this type of resolution, something that's not been possible before. As I said, usually you sample one area, or you might move around depending on how much time that you have. So we can begin to look at effects on much larger scale than was previously possible. And we can begin to see things like these cracks, which were important for the conservation work that's ongoing at the moment. And also we can map out the areas of repainting and coatings. And so these are, again, some more details from the two images. So this is an image. This is a little video that we can hopefully will load relatively quickly. So this is just loaded into Lightroom, which has some file size limitations. So these are actually not the full size images, but we can use them to compare them and digitally inspect the wall paintings off-site and begin to plan our conservation campaign off-site, and not necessarily in front of the paintings, or also not necessarily moving around the paintings with lots of UV light, both irradiating us and the paintings for too long. So we can see in areas such as the background here, these areas have been heavily focused upon in previous conservation or restoration attempts. Also, the blue tunic we can see has been repainted. All the faces are muddy and dark due to the application of these phases of repainting. We can also see differences in the repainting. Some of them are extremely fine. Others, like this, are not fine, but I think if we go down we might actually see some. Hopefully I go to somewhere where there's some nice... because we're not sure... immediately after these paintings were created, they began to fail due to this kind of experimental technique called water glass that was used to create them. So actually the Daniel Maclise, the painter, kind of went back very soon after painting these paintings to... I didn't actually cover them, but he went back very soon after painting the paintings and repainted some of them himself in a different material to how they were originally painted. So being able to separate out where Daniel Maclise repainted them and where someone else much later on came and kind of did these washes over the surface to disguise the deterioration that was happening is very important to treating the paintings. So we also have, as I mentioned before, these cracks that were revealed in UV light, and these cracks were known about before, but it seems like they are more extensive than they originally thought. It's likely that they're a result of a bomb that was dropped during World War II, and the way that these paintings are constructed is they are on a lath and plaster support, separated from the main body of the wall with a void, and then dry plaster, and then the paint on them. And so what's happening at the moment is there is work on the windows above. This is the far right image is an image of the work that's happening on the windows that are above the paintings. So quite invasive work with mechanical drills to replace some of these stone elements due to water ingress. And that's having a big effect on these paintings, because you can imagine they're quite a thin material that's quite flexible with cracks running through them. So at the moment the concern is during these works high vibrations are being produced, and it may cause these cracks to fail further and cause loss to the painting. So at the moment we're monitoring the vibrations that are being transmitted through the painting and using these high resolution images to assess if there is any change in the wall paintings, particularly focused on these areas of cracks where you do have a lot of delamination. And so we've used the 3D information that was captured prior to this work to compare the delamination as it is now with the delamination that we can see in the model. So in the case of Greenwich, the imaging that was undertaken was infrared imaging and visible imaging from the floor, a long way away from the paintings. Unfortunately, I had to use a zoom lens and not a prime lens in this case, but it allowed us to both use the images for publicising the conservation project that's ongoing in the house of Greenwich, but also as a tool to inform our conservation decisions when it comes to treatment. And so this is the visible image of the paintings and the infrared image. And when we start to look in more detail at the two images, we can compare them side by side and bring out aspects that we would want to focus on in terms of conservation, for such as the differences that we're seeing in the robes here are probably areas of repainting or a selective use of non-original coatings, which are now failing. And this is an example of the images combined, and at the end is the infrared false color image that shows up much greater in terms of the looking at a larger scale. Using the infrared false color image allows us to quickly identify areas that may be of concern for the conservation of the wall paintings. And I will just skip through these and acknowledge a few people who have been involved in the project. Caroline Babington at the Houses of Parliament, also Payne and Stewart, a conservation company in London, and the Courtauld Institute of Art, and Sri Kumar Memnon from India. Thank you.